We're excited to offer you today's webinar on the importance of using the right charge controller in a battery-based solar or UPS power system to maximize power. We'll cover the differences between several Morningstar charge controllers and how they were used in 3 different SunWize power and battery system applications. Before we get started, we encourage questions, and we'll address these during the Q&A following the presentation. Please use the questions box on your dashboard on the right side of your screen to email questions. You will be in listen-only mode during the presentation. Okay, leading our discussion today is Mark Perry, Senior Sales Executive with SunWize Power and Battery, and Doug Grubbs, Application Sales Engineer from Morningstar Corporation. Since 2009, Mark Perry has been one of our senior sales executives. He has vast experience in remote, battery-based solar power systems and industrial components. Doug Grubbs is an Application Sales Engineer at Morningstar and is involved in Morningstar's regional and global sales engineering efforts. He is experienced in solar PV design and battery-based solar power systems and served as an electronic engineer with the Federal Communications Commission for over 9 years. Mark and Doug, can you say hi to the people?
Hi, this is Mark. How are you? Thank you for showing up.
Yeah. Okay.
Yeah, thank you for doing this webinar.
Yeah, we're excited to have you here. SunWize Power and Battery. For over 20 years, we've been developing engineered battery-based system solutions for backup applications designed for our industrial customers. You can see some pretty cool pictures of some of the systems we've done. Thousands of our systems operate successfully on all 7 continents. We provide cost-effective and reliable solar power systems for outdoor equipment where utility power is unavailable or impractical.
Thank you, Marcia. I appreciate that. This is Mark Perry, SunWize Power and Battery. I'm talking to you guys out of San Jose, California, but we do have locations throughout the United States. So I just wanted to have a real quick comment here. I'm going to try to stick to my slide timeline. So if you feel like we're moving a little quick, that's what the Q bar is for. This discussion is primarily about our systems and Morningstar's products inside of our systems. Again, one of the most important things to remember is that we provide power systems that are typically for difficult locations where you can't get utilities, or where if you can get utilities, it's terribly expensive to get to the location. We offer products that range from 1 to 3,000 watts continuous, and those change in terms of the design. The smaller they are as they get bigger. And just one quick reminder that every single project starts with the worksheet. We'll show you that worksheet a little bit later. But those are kind of the 3 real quick things I wanted to talk about up front here, and just say thank you guys for showing up. Go ahead, Doug.
Thank you, Mark and Marcia. Morningstar has been supplying off-grid solar charge controllers and inverters for over 20 years. And many of our installations around the world are SunWize systems, and their systems have proven to work in a variety of rugged environments. We are 100% focused on our core competence of off-grid solar power electronics, and we have patented technologies that are designed in the U.S., and our engineers continue to develop and improve our new and existing products. So that's basically everything about Morningstar. We have a website with a great deal of information about all of our products, and I'll turn it back to you, Mark.
Thank you, Doug. Appreciate it. So the next slide gives you an idea of where these installations might be located. Again, as Marcia mentioned, we have installations on all 7 continents. You can see Antarctica there in the middle top, where they were actually tracking the migration of penguins. Top left is a a wireless application out in the Mojave Desert. Other things you can see there that we monitor flow of glacial flow and tectonic plates. Indonesia, there was an airport application in the Florida Keys. That's actually Dry Tortugas on the National Monument where they needed extra power. So these are just kind of some of the locations that we can, deploy these things. And in most cases, power just wasn't available. So this just gives you kind of an overview of the applications that we have. So let's go to the next slide. We're going to talk about a few different applications, but why is solar power for this type of application so useful? We can get a very good range of consumption in the watts side of things. A lot of the times that we talk about the utilities, in many cases it's too far away from the utilities, and in some cases it can cost anywhere between 50 to 100,000 miles, $100,000 per mile to get utilities to a location. So an obvious benefit for using one of these systems is it's a lot less costly. DC is one of the ways you can get good power use and not lose a lot when converting, but we can also go to AC. Another big thing is if you have a location that isn't attended year-round, it helps to not have to go out to these locations, when you don't have time. And the other thing is that they can be in very harsh environments. As you can see in that applications earlier, they're in the desert, they're in the Antarctica, and they literally hold up, with some design, very well in these environments. Let's go to the next slide. It's the gas and oil industry is one of the subjects we're going to kind of address out of the applications, and then we're going to discuss the application, and then we're going to hand it off to Morningstar to kind of discuss which charge controller was used in this application. So you'll see here Bakersfield, it was a monitoring application for a gas field. They had a real big issue here is that it was fairly remote. There was no power even though there was oil everywhere. And it gives you kind of an idea of where these things can get placed. So unattended remote site location, desert environment, reliable power, ease of installation. These are all things that were challenges for this installation, and what we chose to use was a power-ready system. I believe this was actually a, excuse me?
Marcia, next slide.
Oh, sorry. There we go. Unattended remote site location, desert environments. Those were the challenges. The solution was a power-ready system. I believe this was about 65 watts on this, and they needed it for monitoring. So Doug, can you give us a little idea of how the Morningstar products are actually used within the gas and oil industry and some of the benefits of using Morningstar?
Sure, Mark. The SunSaver is often selected. This is one of our oldest, I think it was our second product we introduced back in the 90s, and this is the third generation of this product actually, and it's often selected for oil and gas applications because it's certified for Class 1 Division 2 hazardous locations. The SunSaver is a PWM controller that optimizes the battery charging process from the available solar power. It has a float setting, so the battery will stay in float rather than discharge. And by maintaining the highest possible state of charge, the SunSaver maximizes the battery lifetime. Many consumers have reported that their systems last longer with the SunSaver versus other brands which still use older technology such as on-off switching. And it is epoxy encapsulated and also has marine-rated terminals to prevent rust. We offer models with and without low voltage disconnect, which may be needed to prevent your battery from over discharge. The SunSaver is a small controller with, and it's thin rail mountable, so it's easy to install, and that's some of the details regarding the product. And this is really the standard controller for off-grid, especially oil and gas. So thank you.
Perfect.
Next.
Thank you very much. So the next application that we have here on the slide is a power online. And we use this in many cases where they don't necessarily need solar as part of the charging mechanism. It's actually driven right from the utilities. So in this case, it was a track switching application, and the challenge was that they needed to have this track work, but the utility power was only available at night. Seems kind of strange, but if you see that this thing is attached to a light pole, apparently the utilities only came on to that light pole during the evenings. And so what we needed to do was to charge up that battery bank and then allow the battery bank to run the track switching during the day. So what we chose here was a power online system. It can deploy a DC or an AC load, and on this one it was a 72-hour load preference on their side. So if the utilities went out, they would have 72 hours of continuous track switching. So let's just take a little peek here. It was mounted on a light pole near a track area, and what they did was they tied it into this track motor, and as the track shifted, it would take the power from the power online. And then during the evenings when the lights were on, it was still running the track switching, but it was also charging the battery. So the way the power online is designed is that it's got absolutely no, it's continuous power, so it's drawing from the battery bank. It never is drawing from the utility as if it's a utility application and then switches to a battery. So it's uninterrupted. So Doug, on this application, what do you think would work best?
I think we've got a few slides ahead here. I think back 2 more slides here.
Marcia, we need to go to the next slide. There we go.
There we go. Okay, so the application Mark was describing was is for a UPS power online. So not only is the Sun Saver used with solar PV systems, but it can also be used in UPS power online designs, for the continuous power UPS systems for low voltage disconnect and battery charging regulation. One thing to note is that you have to derate the charging current rating for non-solar PV applications such as small DC power supplies. In this example, our short sign inverter is also used to convert the DC battery power to run AC loads. This is not like the little inverters you might find in auto parts stores or Harbor Freight. Nothing against these Harbor Freight or anything, but this inverter provides high-quality AC, which is equivalent to grid power using a toroidal transformer design. That means you get very good quality AC power that will not damage your loads, and especially small motors that may have problems. This inverter automatically powers down to standby mode to reduce self-consumption. It's rated for 300 watts continuous power and 600 watts for 15 minutes. So it's only for small loads, but you get the really good quality power, AC power for those loads, which in many applications means you're getting what you need for those loads exactly. It also doesn't have fans like many other small inverters have, so it doesn't bring in dust and debris and you don't have to worry about a fan which might stop working. So I think you can go on to the next slide now.
Okay. The third application is telecommunications. That's a pretty large sector with SunWize Power and Battery. This application was in the Mojave Desert. It was for a telecom repeater site. And on this, it was a very large array, but it also had a generator backup. So this is a hybrid solution. And then there's a few other things that I'd like to actually chat in about later on about using generators and batteries. So for cycle charging, which is another project we're working on here. Anyway, we're asked to come up with a solution for the middle of the desert. Next slide. Oh, so excuse me, previous slide. Sorry about that. There we go. Anyway, it was they needed reliable power, obviously. Being a wireless company, they needed to make sure that everybody's phone calls jumped the desert quite well. But it was a very remote and unattended location, so you can see by that photograph that there's a chain link fence and barbed wire, so nobody was really out there, with the exception of showing up to drop off diesel every, I don't know, it was about every quarter, every 3 months. The solution that we did was a dual power station. You can see that's a 7,680 watt array and a generator that was attached, large battery bank. And you look at this thing, you say, well, how difficult is that to install? That's actually a fairly easy installation. Post-prep of the site, you're probably talking 4 days, 4 guys on this thing, one being electrical, mechanical, and the others just being mechanical guys. So they're relatively easy to put in. They're plug and play. So the next slide is about the charge controllers that might be used in the communications niche. We'll have Doug talk a little bit about that.
So as Mark mentioned, SunWize is pre-installing the wiring and everything, so it makes it really easy to install. And for larger telecom systems like this, you'll have larger arrays and bigger modules, and MT BTW controllers are used with larger systems often because they can handle higher voltages with several advantages, including fewer strings in parallel and smaller wiring with less voltage drop. With the MT BTW controller, the array can operate at maximum power, so it can generate more power than a PWM controller would. So many of our controllers include RS-232 serial communications. In addition, the Tristar MT 60 model also includes EIA 45 serial and Ethernet for remote internet access. Therefore, you can monitor many parameters of the system remotely. It also allows you to connect Ethernet to EIA 45 bridge for remote access to other Morningstar products at the site or even other EIA 45 components. Additionally, you can create SNMP and email alerts to receive notifications about critical conditions of the system. We offer an optional Tristar meter, which you can see in the Tristar controller on the right. A single meter can display information from multiple controllers using our meter hub accessory. The Tristar, which is our biggest PWM controller, can also be configured for load control with low voltage disconnect. We also offer a relay driver for low voltage disconnect or for automatic generator start, since it can control up to 4 relays, 4 relay switches. So there's a few reasons why you would want to choose either a Tristar PWM, the one above on the right, or the relay driver for LVD. So there's a few advantages of either one. The relay driver may give you the option of prioritizing loads and things like that, and the Tristar gives you more information capabilities about the current and things, the load currents. So SunWize has a lot of experience to make these kind of decisions, and this is where we value our partnership with SunWize. Their expertise in system design means that you'll get the correct configuration for your needs. You can have the best batteries, PV modules, and solar controllers in the world, but you could experience big problems with damaged batteries, unreliable performance, or even sometimes people damage their equipment because they don't have the right configuration for the system if it's not designed properly. There are a lot of details to consider, even in small systems. For example, our controllers have presets for different types of batteries. In addition to the presets, there are basic and advanced custom settings. We include temperature compensation. We offer meters and communications accessories, and our products include electronic protections and safety features. We encourage you to take advantage of SunWize's support for our products, which will help you take full advantage of all of our controller features and capabilities. So let's discuss the Tristar MT BTW advantage on the next slide, so you know more about that. So this slide illustrates the difference between PWM and our Tristar MT BTW technology. The PWM controller does not include DC to DC conversion, so it will operate below the maximum power voltage as shown in the gray area on the graphs. Associated with all modules and arrays is a maximum power voltage where the greatest power from the array is possible. The MT BTW controller, on the other hand, operates on the maximum power voltage and will produce more power than the PWM. This is sometimes referred to as MT BTW boost, which will typically be 5 to 25% more charging power than the PWM from the same array. As discussed in the previous slide, MT BTW also allows the use of higher voltage strings for wiring cost savings and other lower costs associated with that. And sometimes there's modules that can't be used with PWM controllers also. They're sometimes less expensive to purchase. So the Tristar MT BTW technology is different than other MT BTW solutions found in the industry. One important aspect of MT BTW controller is that it operates at the maximum power voltage as often as possible. The Tristar MT BTW controllers make fast sweeps of the entire IV curve in less than half a second, allowing it to sweep more frequently to better maintain the true max power point. Morningstar's real-time tracking is much better than other MTB solutions that have problems accounting for daily temperature and irradiance or mixed string voltages due to shading or mismatched modules. Another important feature is the efficiency of the DC to DC conversion for the Tristar MT BTW controller, which we'll show on the next slide. So on the next slide, we have the efficiency. Marcia? Okay. The previous. I think we're missing that slide. So in addition to having highest peak efficiency of 99%, the Tristar MT BTW has higher efficiency at both low and high power levels, meaning that you'll have more power when it's needed. It comes on earlier in the day and stays on later in the evening, so you get as much charging to your controller as possible. And also, besides having the higher efficiency at low power levels, there's higher efficiency at high power levels, which means that it doesn't overheat as much. Some MT BTW solutions have more than 2 times the energy losses at high power levels. That doesn't just mean loss of power, but all that power gets transformed into heat, making lower efficiency controllers very hot. So Morningstar is one of the few manufacturers that offers MPB controllers without fans, and fans can be less reliable. That means that you may have to go out to the site to change the fan or the controller. And one of our installers told me he was using Morningstar because his installations were only accessible by helicopter. So you can imagine the added cost of adding the site to having to access the site just to replace a fan. So fans also can pull dust and debris into the controllers, and and so I was at a site. I was at many remote sites recently where the Tristars look brand new inside, even though they were covered in dust. And so, for in dusty environments, it really makes a difference. And especially when you're in the desert or something. So I would say the Tristar MPB controllers with Trackstar will typically provide 2 to 7% more charging energy on a daily basis from the same array compared to many other MPB controllers on the market. So we can move on to the product applications chart.
Okay, great. Thanks, Doug. As you can see from this chart, Morningstar has developed their product line over many years with a proven reliability in all relevant application markets as shown on the left. The chart demonstrates the scope of available products that Morningstar offers, and that SunWize Power and Battery uses for our system designs. Morningstar works closely with our design engineers to develop proper charge controller integration into our systems. Doug, Mark, do you want to add anything to this?
I'll just add a quick note in here that this is by far not the full list of applications, obviously. We do everything. I'm working with a guy that uses RFID technology to trigger cameras for zip lining in the tourist industry, to trigger the cameras while these clients are going down the zip line. So a lot of, you can use these controllers in our systems for just about any kind of power need.
Great.
Doug,
Thank
want to add to that?
I just wanted to add that this chart is a good guide, but there's many applications where there could be exceptions, and just wanted to mention some of the products we didn't talk about yet. Is our starting from left to the right, our Tristar MPBT 600-volt controller uses very high voltages and can be used with. That's really useful for long-distance wire runs, typically over 100 feet. That's where it starts making more sense. The SunSaver is a smaller 15-amp MPBT controller that has LVD and can be programmed for daily on-off lighting control. The Sunlight features 9 presets for lighting control, including dusk till dawn and evening timers, with and without pre-dawn timing. The ProStar is nice because it's available with a digital display and really easy to see what's going on with the system. The SunSaver Duo can charge 2 different 12-volt batteries, so it's great for RV and marine and other mobile applications. Finally, the SunKeeper and SunGuard can be installed outdoors with no enclosure. The SunKeeper is also certified for hazardous location, making it often seen in oil and gas applications. And the SunGuard is our smallest controller we offer. The only other thing I'd like to point out again about these Morningstar products is that they're designed for remote systems where reliability is a very important factor. Our materials are made to withstand the test of time, and we're conservative in our power ratings, and electronic protections include automatic recovery from faults. And if you have the right settings and system components, you should be able to set it and forget it. So I hear people say that a good bit. So.
Okay, thanks, guys. Yeah, it's quite a great chart. Okay.
We have more to talk about SunWize here. I think you want to know about the SunWize services, or?
With the service side of things, what we tend to do is, again, we start with the worksheet, we reverse engineer your loads into a solution, and then then what we do is we come up with a baseline, and at that point we can start managing the actual components that are used, and then we can go through that together with our sales team and the client to find out some of the nuances of what they're trying to achieve. And most of the sales folks are pretty good at that, but if we need to, we can bring in our engineers. They will give a good evaluation to the sales team. And if needed, our engineers call the engineers over at Morningstar, and they work out the details, and then we present you with a relatively simple description of that, because in some cases it can be very technical, and a lot of the times it's a little bit hard to understand. But rest assured that our teams work together to get you the solution you're looking for. And it may be a combination of relay drivers, charge controllers, inverters and whatnot on some of those large systems. So it can be a little daunting, but with our teams working together, it's relatively easy to get the solutions.
Great, thanks. So we can't emphasize enough how important our relationship and partnership is with Morningstar. We go to them for all our charge controller needs, and our systems integrate the proper charge controller and are documented with our engineering specs. The test results from our pre-shipment performance testing are also documented. Morningstar charge controllers are a vital component in our systems. Our integrated systems include other highly reliable components which also support the Morningstar controller. Mark, would you like to elaborate on any of this and the integration of our components?
Yeah, on this, it's again, it really boils down to the relationship that we've had with Morningstar. I think one of the key deals here is that we also sell a lot of components, but we also use these in our systems, and the beauty of Morningstar is that they have always supported us on any kind of warranty issues that might need to be addressed. So typically it's a very quick turnaround. They do an analysis of what was, what the problem is. Together we work to finalize the solution. So going to components, one of the things that SunWize does do is for those of you guys out there that actually like manufacturing, things, power stations, power solutions, we sell components. But the one thing I wanted to emphasize, and we're going to toggle back and forth between this slide and the next slide, Marcia, is those are the components. If you can toggle to the solution, the pre-engineered solution slide. And I wanted to kind of go back and forth between these. Marcia, you got the next slide?
Yeah, sorry about that.
So this is those parts on the previous slide put together. This was sent out in a large size crate, everything pre-engineered, pre-wired. Essentially, as I said, 4 or 5 guys put this power station in about 3 to 4 days. Go back to the previous slide. It's important to remember that in our power stations, there is likely over 200 parts. We're only giving you a quick smattering of those parts, but there's bolts, there's nuts, there's wiring, there are connection points, there literally over 200 parts that you have to concern yourself with, whereas going back to the next slide, Marcia, there's the solution. The next slide. That one, there we go.
Sorry about that.
The solution. So the difference is, and don't go back to the previous slide, but the components, all of our components have manufacturer's warranties. This solution also has a SunWize warranty, so you're getting a 1-year warranty from the overall functionality of it, and then obviously the manufacturer's warranties, including Morningstar, run the duration of that component itself inside of this piece of equipment. So this was just kind of sort of a visual on all of the different things that go into a system and what we provide as a total solution. Again, this showed up in probably 1.5 crates. It's on an A-frame. Those arrays, 3 different arrays, were pre-built, pre-racked, pre-wired. You can see those wires on the back. Those are going to get dovetailed right into the battery bank and charge controlling unit that the guy is standing on, and then the equipment, load block, and quite possibly any kind of your own installed equipment would be on that right-hand side aluminum enclosure, which is tied into the battery bank. So typically the most difficult part of this is the site prep. This was relatively easy. They just did sonnet tubes, and we did legs to the sonnet tube. So that's kind of a good back and forth between the component side and the systems that we do. So if we go to the last power slide there, yeah. This is, again, just an overview of the 3 different systems. The Power Ready, typically 1 to 100 watts. And again, I say 100 because we can get away with 100 watts continuous in Texas. If you're in northern Maine, it's probably going to be 1 to 75 watts. They can be built in configuration of 12, 24, 48 volt. And again, if your equipment has a very small tolerance, we can also install DC to DC controllers that will tighten up that variance so that you've got the ability to tie into your equipment without any issue. Power stations, the next one over, a lot of use of that in gas and oil, communications. Again, continuous power from 100 to 3,000. The 3,000, again, is not typically all batteries. It will probably have some sort of hybrid component in it. Again, configurations 12, 24, 48, plus any kind of AC that might be necessary. We can get up to 8,200 watts in terms of the size of the array. Battery capacity is up to 7,000 watts, or 7,000 amp hours. And again, the Tristar, the MT BTW Tristar would be the solution from Morningstar. And then the power online, again, is essentially a backup. In most cases, it requires utilities, but in some cases, folks will actually install a small array for a backup to the backup. So that's in some cases where safety is paramount. And online will use the utilities to charge the batteries, but then they may even include a small PBK kit, which is just a solar kit that keeps the batteries charged during the utility outages. So that was longer than my allotted 30 seconds, but what the heck. Then Mark said the next slide is the sizing of the system. So why don't you just review that real quick, because you tend to have to say a lot.
Yeah, this is a snapshot of our project worksheet, and this is what we use to size our systems. So you can find this on our website, or we're happy to email that to you as well. And basically, what we're looking for is we want to be able to accurately size and quote your project. So we want your loads, we want to know the voltage, the watts, the amps, the duty cycle, the voltage range that your load will tolerate, along with the project location. As Mark pointed out, that's really critical, and we use sophisticated weather data. And then we'll work on this and get back to you with a quote. So you can find this, like I said, on our website, but we're also very happy to send that to you. So just let us know how we can help. Mark, do you want to add anything to that? Or?
Yes, sorry about that. I was on mute. I like the fact that we can actually have guys just have this as a download from the website. You can see the location is sunwizepower.com resources, and then under the downloads page, you're going to download the industrial sizing worksheet. It's nice to have that on your desktop kind of tucked away, because every project that starts with SunWize starts with a brand new sizing sheet. The reason we do that is that the same exact system that you might be working on deploying a 5-watt load across the country will have a different configuration in southern Texas versus northern Maine. Again, it's all about solar insolation values. But again, the key is, the most important thing here is obviously the DC load, the AC load. That's pretty straightforward. But it's the load, the location, and the length of time. Those are the 3 L's that we kind of have been pushing. We need to know the load, we need to know where it's going, and we need to know the duty cycle or the length of time that piece of equipment is actually running. That can be a big differentiator between the sizing of a system. So in a lot of times, guys will just, let's just call it 100% duty cycle. Well, you're basically over-purchasing, because if it's only a lighting solution, we know that it's only going to be about 50% duty cycle unless they're going to keep their lights on during the day. So that's one of the key points, is to know how long that system is going to be on. Marcia?
Yeah, thanks. Yeah, we want to make sure we price it correctly, and this information is vital in order for us to do that. Okay, we are at the Q&A portion of our webinar, and I know that some people have been typing in that they've had trouble with the audio. So we're going to take just a few questions, and I wanted to, I'll read the question, and then we'll open it up to our panelists to respond. So thank you again, Mark and Doug. And okay, so the first question is about OEM for manufacturing. Why do you do OEM for manufacturing systems? We'd like our name on the system.
Okay.
That sounds like a Mark question.
That sounds like a Mark question. Yeah, we get a lot of inquiries about OEM and their brand on our equipment, and that is absolutely not a problem. We've done that with a number of clients where they are essentially a sales organization, not so much a manufacturer. They started making some of their own equipment, realized that they didn't want to be in manufacturing, they just wanted to go sell stuff. They used 2 different packages. One was a 5-watt and one was a 7-watt. And then what I did was I created a very easy org chart sort of matrix so that they could actually go and find the solution for that load based on solar insolation values, which is a very easy click to a map. And then they would have a baseline of what they needed. They had a budgetary number for their clients. And then if there was any modifications, then we would get a fine-tuned number. But they also wanted to make sure their name was actually on the equipment instead of SunWize's name, and we're fine with that. So just so you guys know, we can actually do equipment for your company.
Cool. Okay, great. This sounds like one for Doug. What happens if I exceed the nominal wattage ratings of your MPPT controllers?
Okay. Our MPPT controllers have a nominal power rating, and this rating is basically the maximum charging power. So as you know, if you're familiar with solar PV power, the power may or may not reach even the rating of the panels, depending on where the temperatures and location and tilt and time of day and time of year. So it is possible to adjust the sizing as desired, and if you do oversize it, it's not a problem. It's just a matter of how much time it might be in a derated. Basically, will just limit it to the max power generally. So there might be certain times of the day or times of the year where you will have a sort of a ceiling to your power, but all the rest of the time it may make sense, because all the rest of the time you will have the full power from the larger array, even on a smaller controller. So we have like Tristar 60 would be 3.2 kilowatts, so you might make it a little bit bigger, so and then certain times you would get just a little bit of a derating.
Okay, thank you, Doug. This sounds like another one for you too. So is Morningstar going to be coming out with any new products in 2015? What's in the hopper for the future?
Yes, we're always developing new products. Our engineering team has grown significantly in the last, since I've been with Morningstar, and since I've been also with Morningstar, we've also grown in our sales team and marketing. And so we are continuing to develop new products, including the new MT BTW controller and a new off-grid inverter, a larger off-grid inverter, so that you can expect that sometime in mid to late 2015, both of these products.
Great.
Hey, Marcia, I was going to chime in with some new products too, just in case.
Okay, yeah. What's the new project?
One of the things we've been working on is there's a lot of generators out there plugging away, and a lot in the islands throughout the Midwest, a lot of agricultural use for generators. But most of the time when generators are running, you're actually not getting the peak efficiency, or at least you're not using the power that the generator is producing. So what we're working on is basically it's a big battery pack it's for cycle charging. So what happens is the generator will cycle charge the batteries, and when you go to use the energy, you're using it from the battery banks, and that way you're getting the vast majority of that runtime on the generator powering up the batteries, and you're actually using your power as needed, as opposed to many generators actually the consumption is anywhere between 20 to 35% of the overall power a generator is running. And a generator, there's a few smart ones out there, but not many are smart. They just continue to burn diesel, even though you're only using 30%. So in this case, the battery banks get charged up, the diesel generator turns off, you use your power. Once you get into a voltage that is a voltage range that you've pre-designated, that generator will turn back on, fire up the batteries, turn back off, and again, it goes into this cycle of charging the batteries. So that's cycle charging for generators.
Very cool. Doug, tell us about your RS-232 and Ethernet capability of MPPT TS60.
Okay, so our RS-232 is a serial port, which has Modbus capability. Our Modbus specs are available online, and you can use a Modbus program to collect and even to control the controllers. So it's easy to you can monitor also with our available software, MSView, which is available online, and that can also be connected with Ethernet or with RS-232. So the Ethernet is more of a remote communications, though you can connect remotely with our special equipment. We have a communications document that goes through all the details of our communications capabilities, and so that's a very valuable document to see the types of equipment that is needed to be used with the RS-232 and Ethernet, and so monitoring, programming, and notifications all can be set up with these the communications that we offer. We also have a live view for the Tristar Amputee 60, which is basically letting you pull up a remote site on a screen, on a regular browser screen, and be able to monitor it that way as well.
Okay, great, thank you. Mark, here's someone who's asking about pricing, systems versus components.
Systems versus components. Well, obviously components are going to be cheaper in terms of the, buy individual parts, but you got to do it yourself and it doesn't come with a warranty. Systems, again, is one of those things where you can't really put a number on it because there's some specifics that we need to know. Primarily, where is it located? So, for example, a 25-watt continuous load in, again, southern Texas might be a PR 440, and that same exact load requirement in northern Minnesota might be a PR 660 or a PR 900. So you'll need a lot more modules to get that battery bank up to speed because of the environmental conditions. So pricing isn't one of those sort of one price works for everything. But we can get you pricing quickly if you guys need it. Just fill out that worksheet and we will do the engineering behind it and get you a price.
Great, thanks. Doug, will controllers withstand constant vibration as found on compressor sites?
They should, but our controllers, like the SunSaver, has epoxy encapsulation, meaning that when you open the lid off that, all you see is epoxy. You don't see the circuit boards. There's nothing shaking around in there. Our Tristar MT BTW has also been tested for vibration and drop tested, and we have those certifications available. If you're interested, in, we can provide that information for you.
Okay, great. And for our final question here, and maybe you each might want to even talk about this, but Mark, if a controller fails in the field on one of our systems, how do you fix it? What do you do?
Well, normally what you do is a quick analysis of what might have happened. The next thing would be is, in some cases, you would call us to discuss, and we may have just identified a problem that could be on the configuration side, although doubtful. But then what you're going to do is we have what they call an RMA program, which we know that when a system is down, it's not functioning properly. So we have a way to get you that very charge controller out very quickly without any incident. And then in some cases, we like to have that back so we can do the analysis of what in fact actually happened to the charge controller itself. In some cases, Morningstar likes to have these back as well to do some analysis to make sure that there isn't anything that is going globally wrong. But aside from that, it's a very quick turnaround when it's whether it's a component or inside of a system.
And really rare, right?
Oh, very rare. I mean, I have had in a system, I don't think I've ever, and I've been selling systems for a while, I don't think I've ever had a charge controller go out. I have had a few returns with Morningstar, but it was, we did a goodwill thing and sent them new stuff, but it was determined that it was a lightning strike and it fried the whole system. So for actual sort of durability in the field, Morningstar is the best.
Great.
Well, thank you very much, Mark. It's good to hear. Yeah, we get a lot of people saying, "Why isn't it working?" And we say, "What's the battery voltage?" And so, I don't know. And they look, and it's like below 7 volts or something. And basically, a lot of this can be, a lot of problems can be, fixed beforehand by having the right products and having some of the components, but we also are very good with replacing units if there are failures that don't seem to be anything that can be explained as like just a user just a non-warranty issue. So anybody that knows Morningstar there, so you can get a warranty replacement at no problem, and we'll send one right out if there's needed. And I think SunWize will work with SunWize to get that to you. So
definitely great customer service for both companies. Okay, guys, thank you. Thank you so much, Mark and Doug. And thank you, everyone, for taking time from your busy day and for your questions. You'll receive a copy of the webinar recording later this week. And stay tuned for more webinars from us. We welcome suggestions for topics if you have any. And if you'd like an individual webinar for your company, let me know, and we can schedule something like that for you. We're very eager to hear from you. Thank you again for your time. Have a great week. Take care.
Thank you, Doug. Thank you, Marcia.
Bye,
Thank you.
everybody.